So this is the week 7 lecture video for Math 203. Covers chapters 12, 13, and 14, which basically all the chapters are dosage calculations. And all dosage calculations are pretty much done the same depending on what method you use. And the three basic pieces of information you need are what the doctor ordered and what your concentration is. So, I try to call what the doctor ordered the amount of drug being ordered, and what you administer is the amount of medication. Because the medication, I consider the drug and all the fillers and binders that go along with it. Because if a doctor orders 10 grams of drug, you do not administer 10 grams of medication. You have to calculate how much medication do I have to administer to deliver 10 grams of drug into the patient's system. So D is the doctor's order, and I always consider it the drug. Then H in this case, H per Q is your concentration. H is the amount of drug in Q is a specific amount of medication. So, just say for instance, the doctor orders 50 grams of ibuprofen. The pills you have are 25-gram pills. So, it's 25 grams in one pill. Your D in this case would be 50 grams. That's the amount of drug the doctor ordered. Your H is the amount of medication per specific unit. So you have 25 grams per Q, which is one pill. Some books call H A. I'm going to try and keep A to note the amount of medication. So, you have to know what the doctor orders drug-wise. You have to know the concentration of the medication you have on hand, because that'll tell you how much drug per volume. And with pills, your volume is always 1. Q is always 1 with a pill, because pills are all going to be a specific number of grams per pill. Liquids, on the other hand, you have to be careful. You have to identify exactly how much drug is in exactly how much volume of liquid. So, once you identify your information, then you have to do your drug calculation, which there's 3 different methods: proportion, formula, dimensional analysis. So I have dimensional analysis written here. Basically, it's very similar to the formula method, except notice that Q and D are switched, because in dimensional analysis, D is going to represent the drug, and you want to end up with a quantity. So your quantity, your Q over H is your ratio. Normally we look at it as H over Q, but remember in dimensional analysis, the top of your ratio depends on what unit you want to end up with. Okay, so let's look at an example. Okay, so we have an order. Norvir, 200 milligrams is ordered. So that's, doctor says on the order, give him 200 milligrams of Norvir. So you have a bottle on hand, a bottle of liquid. Who knows how big that bottle is? Doesn't matter. That bottle could have 250 milliliters in it. But according to this, it's 80 milligrams per milliliter. So every milliliter in that bottle has 80 grams of drug in it. So proportion method, the amount of drug ordered is to the amount to administer, as is the amount of drug I have on hand per volume. So H and Q is your concentration. I physically have a bottle that has 80 milligrams per every 1 milliliter. So I want to find the equivalent fraction where the numerator is 200 milligrams. So I'm basically calculating how many milliliters do I have to administer. So how many milliliters of medication do I have to administer to get 200 milligrams of drug into the patient? So what you're administering is proportional to the concentration you have on hand. Cross multiply, so we have 200 times 1 is 200. And then you have your 80, you could say 80 times X, or if you want to call it A, because A is the amount to administer. Doesn't matter. So we have to take our 200 and divide by 80 to get A, or the amount to administer. So if we take 200, divide by A, or 80, 2.5. So that tells me I have to administer 2.5 milliliters of medication. I have to physically put 2.5 milliliters of this liquid into this patient in order to deliver 200 milligrams of drug. Okay, so that's the proportional. If we want to use the formula, amount to administer equals D over H times Q. D again is your 200 milligrams. H is your 80 milligrams. And Q is your 1 milliliter. So again, we're basically 200 divided by 80. It's going to give you your 2.5. And remember, these milligrams cancel and you end up with milliliters. Dimensional analysis. A is what we want. What do we have? D, or we have our 200 milligram order. And we want to multiply that. Let me put my unit in there. And we want to multiply this by the equivalency according to our order. The equivalency ratio here is going to be your H and Q. So we want to get rid of the milligrams and end up with milliliters. So we're going to multiply this with 1 milliliter on top and 80 milligrams on the bottom. This way your milligrams cancel. And when you multiply across the top, you get 200 milliliters. On the bottom, you get 80. And that's going to give you your 2.5. So really, if you look at the formula method, A equals D over H times Q, and you look at the dimensional analysis method, D times Q over H. Sorry. They're basically the same thing. D times Q over H. You're just taking the H and switching it. If you multiplied this out, you're always going to have D times Q over H. So it doesn't matter where the H is. If you know how numbers work. 2 times 4 over 5. This is the same as 2 over 5 times 4, or 2 times 4 over 5. You're going to get the same answer either way. So whether you use dimensional analysis or the formula, you're actually doing the same thing. You're still multiplying D and Q and dividing by H. So, and it doesn't matter if you take D divide by H times Q, that's the same as if you take D times Q and divide by H. You're always going to end up with the same number. All right, so the one thing you have to make sure of is your D and H have to have the same units, because in either way they have to cancel. And in the proportion method, your units have to be the same on the top as they are on the bottom. So here, if I have milligram over milliliter on the left, I have to have milligram over milliliter on the right. So with the proportion method, if the D and H don't have the same unit, you're going to have to convert before you do your proportion. Same thing with formula method. You have to convert before you do the proportion. With dimensional analysis, you can convert before you do the calculation, or you can add another conversion factor into your dimensional analysis. Formula, okay, so these are all the same. All right, so here's one. Doctor orders grams, but what you have on hand is milligrams. And converting grams to milligrams is very easy, right? If we remember our number line, here's gram, here's milligram, one hop. So you can think about it as multiplying by 1,000 or moving your decimal over 3 places. So 2 grams is 2,000 milligrams. So if I want to do that calculation first, I could do that, then use my proportion method or my formula method. So I would have 2,000 grams over 1,000, or 2,000 milligrams, sorry, over 1,000 grams times 1 tablet. That's going to give me, and these cancel. I'm sorry. They're both milligrams. 2,000 milligrams. D becomes 2,000 milligrams. We have 1,000 milligram pills. Milligrams cancel, so we have 2 tablets. In dimensional analysis, the order is 2 grams. Well, to convert gram to milligram, you'd have to multiply it. 1 gram is 1,000 milligrams. We want to end up with milligrams, so that's what we want on top. That would do your conversion. Then we multiply by our Q over H, because we want to end up with the number of tablets and get rid of the unit milligram. So this way, grams cancel, milligrams cancel. If we multiply across the top, we have 2,000 tablets. Multiply across the bottom, and you have 1,000. 2,000 divided by 1,000 is just 2 tablets. So it's up to you whether you want to convert first or just throw the conversion into your dimensional analysis calculation. I prefer either way, I guess. Doesn't matter to me. So there's your proportion method. Again, converted to 2,000 milligrams. The doctor ordered 2 grams, converted it to 2,000 milligrams, and I need to know how many milliliters. So that has to be proportional to what we have on hand, which is 1,000 milligrams per tablet. So you cross multiply 2,000 times 1, and then your 1,000 times A, or call it X. Then you divide by the 1,000 because you're trying to get X alone. So you divide by 1,000 and you just have 1X, which is just X. 1X and X are the same thing. So we must administer 2 of the 1,000 milligram tablets to deliver 2 grams of drug into the patient's system. And so here's dimensional analysis showing, here's the H over Q, 2 grams over 1, conversion, milligram to gram, or gram to milligram. And these fractions, it doesn't matter where they're at, because remember, multiplication is commutative. So I can multiply 2 times 3 times 4, 4 times 3 times 2. It doesn't matter what direction. So those fractions, I have it set here, 1,000 tablet, 1 tablet over 1,000 milligrams, 2 grams. I can switch these around and they're still going to multiply out the same. Because on the top here you have 1 times 2 times 1. And on the bottom you have 1,000 times 1 times 1. No matter which way you put them, you're going to get it the same. If I did the 1,000 milligrams over 1 gram times 1 tablet, a 1,000 milligrams over 1 gram times 1 tablet over 1,000 milligrams times 2 grams over 1, I'm still going to get 2,000 on top and 1,000 on the bottom. Because when you're multiplying numbers, the order does not matter. Okay, so let's try this one. Okay, now this one is a little bit different. The doctor actually ordered the amount to administer. He's saying give 7.5 milliliters of amoxicillin. The amoxicillin is 250 milligrams to 5 milliliters. So we can actually use this to find out how much drug the patient's getting. I think the easiest thing here would be proportion. I know there's 250 milligrams for every milliliter, or every 5 milliliters. Well, if I'm giving 7.5 milliliters, that's going to be how many milligrams, or how much drug. So again, cross multiply. You cross multiply the two numbers, 250 times 7.5. And then you're going to divide by the only number left. Because when you cross multiply here, you're going to have 5x. And what was that other number? 1875. So to find out what x is, you divide by 5 on both sides. $3.75. So if we give the patient the 7.5 milliliters of liquid, we'll be administering 375 milligrams of drug. Okay, so here's a note on rounding. In the healthcare field, usually we round to the nearest tenth or hundredth, depending on administration. If it's a pill, form, or liquid, round to the tenth. If using a syringe, round to the 10th. If using a tuberculin syringe, we round to the 100th because a tuberculin syringe is calibrated to the 100th place. Okay, so heparin ordered 4,000 units. Concentration we have on hand is 5,000 units per milliliter. So here's your 3 different methods. Formula, D over H times Q. 4,000 over 5,000 times 1, 0.8 milliliters. Dimensional analysis, here's your strength, but we're writing it. We want to end up with milliliters, so we want the milliliter on the top and the H on the bottom. Multiply that by the 4,000 units ordered. And 4,000 is a whole number. If it's easier for you to think of it as a fraction over 1, that's fine. If you want to leave it as just a whole number, when you multiply a fraction times a whole number, you only multiply the top. So still end up with 0.8, and here is your proportion. 4,000 over X equals 5,000 over 1 milliliter. That's your concentration. And again, we have to administer 0.8 milliliters of this liquid medication in order to deliver 4,000 units of heparin into the patient's system. And that is it for the dosage calc lecture.